In question number 26, 6 parallel plates, each of area A, are arranged parallel to each other as shown. Plates 1 and 4 are connected by a conducting wire. Plates 2 and 5 are also connected by a conducting wire. The separation between any two consecutive plates is D. The equivalent capacitance between points P and Q is, and it is given in the question, the value of C is equal to epsilon 0 A by D. So if I applied the point potential technique, that is clubbing the points which are at same potential, then I can see that this is point P and the potential of 1 and 4 is also same, and this is point Q, the potential of 6 is also same. So if I keep the point 2 and 5 at this point and point 3 at this point, now I have to apply the capacitance between these points. So one capacitance is between 1 and 2, so this is C. Another capacitance is between 2 and 3, so 2 is here, 3 is here, this is also C. Then between 3 and 4, 3 is here, 4 is here. Then between 4 and 5, 4 is here, 5 is here, that is also C. And last between 5 and 6. So if I see this arrangement, I can say that these two C are in series, then they are in parallel with these two C capacitors. So the equivalent of this combination, if I write, that is equal to 2C plus C by 2. So this comes out to be 5C by 2. And this 5C by 2 and C are in series. So C equivalent between point P and Q can be said that 5C by 2 into C divided by 5C by 2 plus C. So that comes out to be 7C by 2. On solving, it comes out to be 5C by 7. So option 1 is the correct answer. Let's move to question number 27. In question number 27, electric potential at a point in XY plane is given by V is equal to X by Y. Then electric field intensity at point 2, 3 is. So from the relationship between electric field and electric potential, we know that E is equal to minus partial derivative of V with respect to X, I cap, plus partial derivative of V with respect to Y, J cap. The potential function is given in the question. So if I differentiate the potential with respect to X, then it would be 1 by Y, I cap. And if I differentiate with respect to Y, then it would be minus X upon Y square, J cap. So on substituting the value of X is equal to 2 and Y is equal to 3, we will get minus 1 by 3 I cap plus 2 by 9 J cap. So option 3 is the correct answer. Let's move to question number 28. In question number 28, two dipoles having dipole moments P1 and P2 are arranged as shown. The separation between the dipoles R is large as compared to the dimension of the dipole. It means we have to consider this dipole as a small dipole. And the force between the dipoles is. So if I consider the force acting on dipole P2, then the electric field at the point of P2 is in this direction. And this is equal to 2K P1 by RQ. So if I write the electrostatic potential energy of the dipole P2, so that can be written as minus P dot E, so minus P2 into E, that is 2K P1 by RQ into cos 180 degree, that is minus 1. So it comes out to be positive. So if I calculate F, that is equal to minus du by dr. So if I minus differentiation of this is 2K P1 P2, differentiation of 1 upon R cube is minus 3 upon R raised to the power 4. So it is equal to 6K P1 P2 upon R4, and since force comes out to be positive, so it is repulsive in nature. So option 4 is the correct answer. Let's move to question number 29. So in question number 29, the volume charge density of a solid non-conducting sphere varies with distance r from the center of the sphere as rho is equal to rho naught by r, where rho naught is a constant. Then the electric field intensity at a distance r from the center is. So this is the solid non-conducting sphere. We have to calculate the electric field at a distance r. So in order to calculate the electric field at a distance r, if I consider a shell at a distance r of thickness dr. Then let's check what is the charge enclosed in this sphere. So in order to calculate dq, we can write rho, that is rho naught by r, into 4 pi r square dr. So if I calculate the charge enclosed in a radius r, then that will be q is equal to integration of dq from 0 to r. So 4 pi rho naught into r dr integration 0 to r. So integration will give r square by 2. So it is equal to 2 pi rho naught r square. Now we have to calculate the electric field intensity at a distance r. So at this point, the electric field intensity is only due to these charges which are enclosed in a volume of radius r, and the electric field due to outer charges at the inner point is 0. So this charge we have calculated. So if I calculate the electric field at a distance r, that is equal to 1 upon 4 pi epsilon naught q, that is 2 pi rho naught into r square divided by r square. So on solving, it comes out to be rho naught upon 2 epsilon naught. So option 1 is the correct answer. Let's move to question number 30. In question number 30, 2-point charges Q1 and Q2 are kept as shown. One of the electric field line coming out from Q1 makes an angle of 30 degree with the line joining Q1 and Q2. Terminates at Q2 making an angle of 60 degree. The ratio Q1 by Q2 is. We see that the charge here is negative as the electric lines of force is terminating at this point. So I can say that flux through this angle would be Q1 by epsilon naught. This is the total flux through charge Q1. The solid angle for a sphere is 4 pi. So divide by 4 pi. So this is the flux through a unit solid angle. And the solid angle of this will be 2 pi into 1 minus cos phi. So if I multiply the solid angle, that is 2 pi into 1 minus cos 30 degree, that is equal to minus Q2 upon epsilon naught divided by 4 pi into 2 pi into 1 minus cos 60 degree. So if I solve the value of Q1 by Q2, so it comes out to be minus 1 upon 2 minus root 3. So option 2 is the correct answer. So by this, I wish you all the best for your preparation. Have a good luck. Thank you.